robotics. I'm a research assistant here at Daniel Aukas's lab, and here we have a Vive virtual reality system. So if you haven't actually tried virtual reality, you should, because it's amazing. And so I just pop this on, and we have a table aligned with a virtual table, just so that I can put my controllers down and they don't fall, and just it feels more realistic. And so what we have here, I can see my controllers like they would be in real life. I can press triggers. I can even grab virtual objects, and what's good enough, I can juggle. And the point of this is that we have a virtual robot here that we can interact with.
Hey, so welcome to my virtual kitchen / robot arm lab, and here I'm going to show you my virtual uArm simulation and how you can simulate robots and record them doing all kinds of cool stuff in this VR sim. All right, let's get started. So what you have here is a virtual uArm, and the uArm is the brand of robot arm made by uFactory. And so I basically recreated it in a game engine called Unity. And so I took all the linkages and everything from their publicly available STL files, and I separated them and I put them into Unity, gave them some textures, put some colors on there. This was my first experience making games, so it's very rough around the edges. But then I attached all of the joints with hinges. That's a game object type. And so the Unity physics engine is taking care of a lot of the rest. So once I put collision boxes on all of the pieces, suddenly you can, the robot moves like it should, it acts like it should. Took a lot of fine tuning, but it's finally a real virtual robot. So you can see it's you can press it against the table, and it's moving like it would normally, maybe with a little bit less friction than it should. But yeah, that's the general idea. And so one key feature of this game or simulation is that you can record the robot's movement and replay it. And the suction cup and the pump and all those things are simulated as well, so that you can interact with virtual objects and have sort of, automate things in your virtual kitchen or world, right? So here it is replaying the movement that I just showed it. So as an example of picking up an object during a recording, in this one, I set it to recording mode, and then I press the trigger on the Vive controller, so the pump is now on, and you can see it picked up that virtual object, and the end effector can still be moved. And I drop it by letting go of the trigger, drop the robot, and then I play. I threw the cube out of the way to get to the starting position, so that was kind of an accident on my bad. But you can see here now it's recording, and it's playing back with the pump at the same state that it was before. So the main reason I started working on this project was twofold. I wanted to be able to program robots in VR and have unlimited robots and do all kinds of cool stuff. And I also wanted to get people interested in robotics who are using high-tech stuff like Vives. And I also thought that being able to look at the kinematics of a robot in VR is so useful, because you can see exactly how things are moving and interact with it using your hands. And that's just something you can't do in 3D with a mouse and a keyboard. I think there's just so many more uses to virtual reality than just gaming, and that we're just barely starting to scratch the surface of what virtual reality can really do for us, especially in a field like robotics, where you have to really think in 3D, think about all the axes, the robots, the joints moving. When you can just pop on a headset, see the robots, see the hinges, see the interactions, the kinematics, it's going to help the design process a ton, both in education and professional use.